I'm building a bushcraft themed survival game, and so far we've got a cool little fire mechanic, as well as a chaotic large fire mechanic, procedural terrain generation with realistic plant placement, a beach with waves, and some other little features we've talked about in previous videos. Mostly what I've been focusing on is building the core mechanics for how the game world works. But all of what I've worked on so far is contained within just one static slice of the game world about 50 tiles wide and 75 tiles high. The entire point of this game though is to capture the experience of the old Australian swagman, and that means the player needs to be able to travel long distances on foot. 50 tiles does not make for a particularly long journey. I want the player to be able to travel infinitely either east or west. And so I need a way to procedurally and smoothly create more terrain and items as the player walks. So let's zoom out and take a look at the basic idea I had. I start off with just one initial chunk of terrain in the middle of the screen. This is just what I have already, but now there is extra space to the left and right. Now I can fill these spaces with extra terrain for the left and right chunks. Later I will generate new terrain for these other chunks that smoothly transitions, but to begin with I just make copies of the same terrain. Now we have 3 chunks loaded in at once, and I have these 2 imaginary boundaries on the left and right chunks. And this is where the trick comes into play. I detect when the player hits one of these boundaries, and then basically just shift the player back to the center of the screen. At the same time, I also shift the terrain and all of the items. So when we are zoomed out like this, we can clearly see the player is just teleporting back to the middle, but when we are in the normal zoomed in view, the player won't actually see any of this happening. To them, it will appear as though they are just walking normally, but really they are walking on some kind of weird teleporting reality bending treadmill. The ocean tide was actually a bit of a problem for this initially because it just spans the entire width of the chunks. If you were walking near the shore, you could clearly see something funky was going on when you get teleported. So what I did basically was just adjust the frequency of the sine wave being used for this shoreline so that it repeats evenly between the chunks. This way, if you are teleported from the middle of one chunk to the middle of another chunk, the position of the wave would be the same, and so it wouldn't be noticeable. This is one part of the problem solved, but as well as resetting the player's position back to the middle chunk, I also need to generate the terrain and items for the new chunk in the direction they are walking. This was problematic though, because I needed to generate about 900 items for the new chunk, and this led to noticeable lag. But all of this happens off screen for the player, so there is no need for me to immediately create all of these items. So what I did was set up a way to batch these item creations so they would be added over multiple frames rather than trying to do all of the work in one frame. As you can see now, as the chunk changes, the new items load in this staggered fashion. Then it was time for the big hard problem that I knew was coming. So far I have just been copying the same terrain from the middle chunk for the new chunks, but I of course want to generate new terrain as the player walks. The problem is that I'm using a wave function collapse algorithm to generate the terrain, which is computationally expensive and slow. This is fine for the initial load, but I can't really have the player wait 5 seconds for the terrain to generate every time they hit a chunk boundary. This game is built with JavaScript, and JavaScript is single-threaded. But what I was able to do is offload the wave function collapse calculations to a web worker. Web workers provide some form of multi-threading in JavaScript, but worker threads don't have access to all the same features as the main thread. This includes access to the DOM, but fortunately I don't need that to run the algorithm. So the main thread would make a call to the web worker to do the terrain generation. Once the terrain generation is done, it would send the result back to the main thread, and then all the main thread has to do is render the resulting tiles to the tile map. So now rather than having 5 to 10 seconds of blocking time on every chunk change, we have none. That wasn't the only big problem though. I can't just generate a new chunk of terrain in isolation using the wave function collapse algorithm, because the newly generated terrain needs to transition smoothly from the old terrain. I'll have a link to my full wave function collapse video if you're interested in the mechanics more specifically. But one of the fundamental ideas is that each tile position in the grid has a set of tiles that it could possibly be. Initially, any tile position could be any of the tiles in the example input. But once we collapse or choose a specific tile for one location, it limits or constrains what its neighboring tiles can be, because not all tiles can be next to all other tiles. So what I did to smoothly transition terrain is essentially pre-constrain one side of the generation. If the player is moving to the right, I would take the rightmost column of tiles from the terrain I am transitioning from, and then pre-constrain the leftmost tiles in the new terrain being generated to only tiles that are compatible with those seed tiles in that direction. If we take a look from the zoomed out view, we can see this terrain generation kick in, because initially the old terrain is still there, but once the wave function collapse algorithm completes after 5 seconds or so, we can see this terrain is updated in a way that smoothly transitions instead of having this obvious seam. And so if we combine all these things together, the player can now walk infinitely in either direction with almost no noticeable seams or transitions or loading time. There is still sometimes a slight noticeable jump or bit of lag when a transition occurs, but it's probably already within acceptable limits, and I could probably also optimize this some more later on. The cool thing about this is that now it will also be easy to smoothly transition into other biomes as the player walks. But for now I am just focusing on the core features, and there is still just one more core feature the game world needs before I can shift focus onto the survival mechanics, and that is a day-night cycle. So that is likely what I'll work on for the next video, and I'll potentially combine a weather system in with that as well. Not because it's totally necessary right now, but I just really love rain in games. So if you'd like to keep following along, feel free to subscribe, and if you found this video interesting at all, a like before you go would be greatly appreciated. Thanks for watching, and I hope to see you back here again for the next devlog.